is a little introduction into the last lab of the course. We're going to be studying momentum before and after collisions for a system. The system will be these two cards and whatever we have on top of them. So for this lab, you'll need a dynamics track, get it nice and level, 2 photo gates, 2 cards. Each card needs to have a flag of some sort on it. You can make one out of cardboard and tape it on. This happens to be one that Pasco makes, and I've adapted for Vernier cards. For these 2 cards, you will need to have magnets in one end of each card. So here and there. That is so when they collide, they will bounce off each other. The other end needs to have Velcro. So if the card doesn't already have it, you will need to add some. And the reason for that is that when the cards collide, we can have a collision where the 2 cards stick together. In the Net9 folder, there's a PDF called Collision Data Table. This table tells you on the card on the left, how much mass should it have, what direction should it be moving. Card on the right, how much mass, what direction should it be moving initially. And the collision type, do you want a bouncing collision or a sticking collision? The data that you're going to need to gather in this lab is what is the velocity of each card before they interact, and then the velocity of each card after they interact. So if you use the program you'll find in the labs folder of Unit 9 called 2-gate timing, that can be used in Logger Pro. You enter the width of the flag that you're going to use, and it will calculate the velocities for you. Now you want the interaction to take place inside the 2 photo gates, and you don't want either card to be accelerating when it passes through the photo gate. To give you an example of what I mean, if I put the card on the right and go, it is most likely still pushing on the left card when it's going through the photo gate, so that would not be a good trial. One of the more difficult trials to do is when you are putting extra mass on the cart on the right and then getting the cart interacting with the cart on the left. You give it a push, and then you want to make sure that this cart is out of the way, that it doesn't come back before this one goes through the photo gate. Okay? So if your instructions are to have a sticking collision, then we'll turn the carts around so the Velcro will cause them to stick together. This is an explanation of the data table. Now in this lab, the gate 1, the red one, was the photo gate on the left, and gate 2, the blue one, was the photo gate on the right. And this lab has been set up that to the right is positive and to the left is negative. So we can see that the first thing that happened was something passed through the left photo gate. I know it was moving right, so that would be a positive 0.432 meters per second. Soon thereafter, another cart went through the right photo gate. I know that it was moving left, so that should be a negative 0.195 meters per second. Then the cart on the left bounced back through the left photo gate, and so the final velocity of that cart was a negative 0.443 meters per second. And then the cart on the right bounced back through the, or passed back through the right photo gate fairly slowly, and it was moving at a positive 0.109 meters per second.